Okay, is my voice clear? Hello? 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 Hello?
Yes, sir.
Clear na? दोनों भी screen भी clear, voice भी clear.
Yes, sir.
Okay. Okay, so today we are going to start a new unit. So in the last unit we have seen that we have finished the first unit, and that is the introduction to Internet of Things. Now we are moving towards the embedded system for IoT. Like, what is the role of an embedded system in case of IoT? That what we are going to see in this chapter. So obviously, the number of microcontrollers, Cortex M series, are designed for the embedded systems, and the embedded systems can be used for IoT. So we'll also see what is the role of embedded systems in IoT. Let us first of all understand what is system. A system is an arrangement in which all its unit assemble work together according to the set of rules. So system is what? It's an arrangement of different units that are working together and using set of rules. That is what is called as system. Now what is embedded? Embedded means something that is attached to another thing. That is, you're attaching something with the other thing, and both the things are working together. Hence we could say to be as an embed. Now third one is an embedded system. An embedded system can be thought of as a computer hardware system having software embedded in it. So an hardware with software, any system that is using hardware with software embedded in it is called as an embedded system. So you come to know what is system, then you know what is embedded, and then embedded system. So system is nothing but all the units working together with set of rules. Embedded means one thing is attached with the another thing. An embedded system is a system which is having hardware with software embedded in it. It's called as embedded system. And then the Internet of Things. So these all four parts we have divided this whole chapter. That is system, embedded system, and IoT. So what is IoT? Now it is the network of physical objects or person or idea called as things that are embedded with software, electronics, network and sensors that allow these objects to collect and exchange, collect and exchange the data. That means we have already seen this Internet of Things. So system, embedded, then embedded system for IoT. So now these two definitions will be very important. That is embedded system that can be thought of an hardware with software embedded in it, and Internet of Things, that is the network of physical objects or persons called as things that are embedded with the software, electronics, network and sensors that allow these objects to collect and exchange the data. Just a moment, something issue is there. Okay, so Internet of Things is nothing but a network of physical objects or person called as things that are embedded with the software, electronics, network and sensors that allow these objects to collect and exchange the data. So collecting and exchanging the data is by far the most important thing. So we are having embedded system, and this embedded system can be useful for the Internet of Things. Now, what is the importance of the course? This embedded system will be at a cornerstone for deployment of many IoT solutions. Major players in the embedded are aiming to bring these transformations into their product to take an advantage of growing IoT market. So obviously the IoT market is increasing a lot, and for that thing, if embedded zone will be the most heart of the subject. So I do feel so this embedded is aiming to bring transformation into their products. Looking at the IoT market, the embedded system in the IoT applications includes network hardware, to home automation. So this embedded systems in IoT, if I say that IoT is a different part and embedded system is different. So when we are using this embedded systems in IoT applications, you can develop a lot of applications, and that is what the importance of this course is. Now let us see what is an embedded system. An embedded system can be independent system or it could be a part of a larger system. So an hardware with a software is called as an embedded system. So embedded system could be independent system or it could be a part of some larger system. So if you can see that there are large number of embedded systems working together in which each and individual embedded systems are independent or could be a part of the other embedded systems. So embedded systems could be a very large system or it could be a very small system. Now, embedded system is a microcontroller or a microprocessor system which is designed to perform a specific task. So obviously, a hardware with a software embedded into it is called as an embedded system, and this embedded system is having is called as a microcontroller or a microprocessor which is specially designed for a specific task. For example, a fire alarm in an embedded system is an embedded system. When it will sense smoke, it will alert the alarm. So it will give the alarm. That means what fire alarm is an embedded system that could be very useful. Now the next thing is characteristics of the embedded system. Now, if you see that how these embedded systems work out to be and what are the characteristics of embedded system, because even if when we are going to study embedded system, we should be able to understand how the characteristics is, because if you understand the characteristics, then you can embed for different systems to make a larger system. So the first characteristics is that it is a single function. An embedded system usually performs a specialized operation and does the same repeatedly. मतलब अगर एक काम के लिए उसको डिजाइन किया गया है, एक स्पेसिफिक काम के लिए डिजाइन किया गया है, तो वो रिपीटेडली काम कर सकता है. ऐसे embedded systems को हम single functioned embedded systems बोल सकते हैं. For example, you can say that a pager always function as a pager. It keeps on giving out the messages at the pager. So it repeatedly do the same kind of things, and that is single function thing. And henceforth, such kind of embedded systems are called as a single function embedded system. Then the next one is a tightly constrained. All embedded systems have constraints on design metrics. Now, what is design metrics? Design metrics is a measure of implementation features such as its cost, size, power, and performance. So whenever you're going to design an embedded system, you have to consider the constraints on design metrics. Because if design matrix is nothing but it is the implementation of features such as cost, size, power, and performance. So whenever you are going to design an embedded system, you must have the constraints on design matrix, because when we follow the design matrix, then you're going to accept and implement features such as cost, size, power, and performance. It must be of size to fit on a single chip, must perform fast enough to process data in real time, and consume minimum power to extend the battery life. That means it should be small that it can be fit onto the single chip. It should be fast enough in order to process the data in real time and consumes minimum power. So less power consumption will be helpful in order to extend the battery life. So first is a single function in which a specific task will be given to the embedded system and it will do it repeatedly. Second is a tightly constrained. You should have a constraint on design matrix, because design matrix will be implemented for the features like cost, size, power, and performance. Third, tightly constrained should be on a single chip, must perform very high so that they can process real-time data also, and will have a minimum power consumption so that battery life will be more. The third characteristics of the embedded system: reactive and real-time. Now, many embedded systems must usually react to the changes in the system's environment and must compute certain results in real time without any delay. So whatever that has been happening around the environment, in the system environment, it should catch, it should react to the changes happening in the environment, and then it must compute certain results in real time without any delay. See, the most important part in this embedded system is that if it is working in real time, it will be very useful, because the sudden changes that are happening around in the environment or in the system, it should catch it very easily. And when it not only catches, but it also reacts very reactive. It is having a reactive response. So that means there will be no delay. because with delay, if you're going to react, then the system can get hang up. So in that case, the embedded system should actually work in real time, and that too without any delay. Example we can take of this reactive and real time is that a car cruise controller which continuously monitors and reacts to the speed and brake sensors. So obviously you know that car, if we consider a car, it is completely an embedded system, little bit of a complex embedded systems where number of embedded systems are working together, because now the advanced car is having the hardware as well as software embedded in it. So if you could say that if I want to have a car cruise controller which continuously monitors and reacts to the speed as well as the brake sensors. So again, we're going to get the speed sensor is going to get the result from the speed sensor, brake sensors will give the result of depth sensor, and that will help you to control the car. So car cruise controller can be easily monitored in real time. It must compute acceleration repeatedly within limited time, as delay computation can result in failure to the control of the car. So obviously it should compute the acceleration repeatedly, keep on repeatedly accelerating within that specific limited of time. Because if there is a delay, then it may result in the failure of the control of the car. So obviously this whole thing is about controlling the car, and that too with the help of the embedded system. So continuously monitoring it in real time, taking all the information from the sensors and giving the result is the most important thing. And if you find a delay in this real time systems, then it becomes difficult and the failure can happen in the control system. Fourth one is microprocessor based. Obviously, it must be a microprocessor or microcontroller based. So the characteristics of the embedded system will be based on the microprocessor or microcontroller used. Then sixth characteristics is the memory. It must have a memory, as its software is usually stored in ROM. Must have a memory as its software is usually stored in ROM. So उसमें memory की जरूरत है क्योंकि बहुत सारा software mostly ROM के ऊपर ही डाला जाता है. It does not need any secondary memory. Connected. It must have connected peripherals to connect input and output devices. So the embedded system should have the connections of the peripherals so that input and output devices can be connected through these peripherals. Then hardware and software system. Software is used for more feature and flexibility. Hardware is used for performance and security. Obviously, the software should have a lot of features and should be flexible. That is the most important part of software. And hardware, it should give the performance with the security. Now we'll move towards the basic structure of the embedded system. So up till now we have seen what is embedded system, how embedded systems can be useful for IoT. Then we have seen the characteristics of the embedded system. Now let us see the basic structure of the embedded system. If you see that the basic block diagrams of the embedded systems are sensors, A to D converter, processor, and ASIC that has been having a collaboration with the memory. So memory is going to be there, DAC and actuator. Now see, we'll see one by one how this works out. Now sensor actually converts any kind of one kind of physical quantity into the electrical signals. Then these electrical signals are obviously continuous time signals. So you can get the information from a lot of sensors. I have taken example of here only single sensor. There might be a lot of sensors been giving the information. So these sensors will be measured in millivolts, volts. So that will be in continuous time signals. Then it need to be converted into discrete form. Hence it is given to ADC, that is analog to digital converter. So as we know that the sensors nowadays are coming with self amplification, like even the weaker signals gets an amplified. So the signal amplification will be carried out in the sensor itself. So it will give you some kind of voltage or millivolts to volt kind of range of the voltage, which is in continuous time signal. And it is given to analog to digital converter. This A to D converter will give you the digital output. Then if whatever we are expecting, if it is not there, it will be again sent back to the A to D converter, so that but this feedback will help you to get the accurate kind of output voltage what is required. Then it is given to processor as well as to the memory. It is given to the memory. So the memory is having three kinds of input. One is the output of the sensor, second is the digital output, and the third one is the processor output. So the sharing of memory with the processor is going to be there. So bidirectional data transformation will be from memory to processor or ASIC. ASIC is an application specific integrated circuit. Like there are processor which does different kinds of multitasking. Like if they are given as a different multitasking, they can do processors. But if you want very specific application based work, then ASIC processors are normally used. So these ASIC processor will be designed for a particular specific application only. They cannot do the other kinds of programming that can be done with the help of processors. So you can choose here what kind of application you want to develop. So according to that development of the application, the ASIC processor can be performed. So processor, if you're going to take, then you can change your programs according to the different applications. So memory is having three inputs. One is from A to D converter, second from the sensor, and third from the processor and ASIC. So when it is connected with the memory, it is going to share this data. The data will go bidirectional from the memory to the processor, from the processor to the memory. So in both the bidirectional data transformation will take place between processor and memory. Then whatever the memory is having, it is having three kinds of input that are stored into it. The first is the output of the sensor. So you know what is the output of the sensor. Second is its discrete value of that output of the sensor. And the third one is the processed output. So that means three outputs will be there to the memory. One is your discrete, another one is an analogous, and third one is a processed, that is with the help of processor. Then this output will be given, this output now it is in the digital form, which is in the discrete form. Now this digital output will be given to the DAC, that is for digital to analog converter. And this digital to analog converter will give you analog output, which will be given to the actuator. Now what is actuator doing here? Actuator is having an reference value stored in it. So what is going to actuator do is that actuator is going to compare the reference value with the output value that is been received, and according to that the output will be given in the end. So in this way, these all blocks will be working together. Sensor will give an censored output, that is in millivolts or volts. Then it is given to A to D converter. Then A to D converter is nothing but the digital conversion. Then it will be given to the processor. It will be processed according to the program that has been written here. The output will be given to D to A converter, and this analog will be given to the actuator, where actuator will compare the reference voltage, reference input with the received input, and accordingly the output will be generated. So I do feel so up till now you have understood the basic structure of embedded systems. You have also understood the characteristics of the embedded system, and you have also understood how this embedded system is important for IoT. Because as we go on, we'll come to know that how these embedded systems can be used for the IoT. This plays a very important role in IoT also, because when we are going to understand embedded system that could be useful for IoT, we are going to the microcontroller based learning. So all these three things are connected together, which will be useful to study embedded systems for IoT. Now types of embedded system. Now you can see that there are the embedded system can be divided into types depending upon two ways. The first way is based on performance and functional requirements. So embedded system can be divided based on the performance and functional requirement. Second will be based on the performance of microcontroller. So two types of embedded systems can be divided. First is based on the performance and functional requirements, and second is based on the microcontroller. So based on the performance and functional requirements, it is divided into real-time embedded systems, standalone embedded systems, networked embedded systems, and mobile embedded systems. And based on the performance of microcontroller, which kind of microcontroller is you are going to use, So according to that, the embedded systems are going to be designed. So they are divided into three types. One is a small scale embedded system, the other one is a medium scale embedded system, and the third one is sophisticated embedded system. So we'll see one by one. Now first is the stand-alone embedded systems. Now stand-alone embedded systems are very simple to understand. Standalone is a type of an embedded system, as the name suggests, does not require any kind of host system like computer or processor, as it works by itself and displays the data on the connected devices or make necessary changes on the devices. So standalone is an embedded system which is individually working. It is not connected to any other embedded systems, neither it is connected to any other processors. It is been stand alone, means it is doing everything itself for what it has been designed, and then whatever it's been doing, it displays the data on the connected device or make necessary changes on the device. Now second one is real-time embedded systems. When an output is required at a particular time, real-time embedded systems can be used. When a task has to be completed on time, or when there is a deadline for the project, this system comes as a savior of the time. So obviously in real time, you does not have to store somewhere, you does not have to process somewhere. Real time means all the processing is going on at the right time, at the exact time. So when a task has to be completed on a time, the real time embedded system becomes very, very important. Or even like I want to complete the whole task within this stipulated period of time, then only the next task can be calculated or it will function. Then this real-time embedded system will become very, very important. So we could say that it is a savior of a time. This is a very punch for the real-time embedded systems. They act as a savior on a time. So they can do a particular task in real-time base. So they can do the task on time, and whenever there is a deadline for the project, this system becomes very, very important. Then the third type is a network embedded system. When a program is running inside another device, a network is formed. This is called as network embedded system, where the running program is controlled by microprocessor or controller. It's very simple that when a program is running inside another device, so there is a device inside a device, and this forms a network. So the inner device is working, and then the outer device will work out. So the whole program will be controlled by the microprocessor or a controller, and such type of systems, embedded systems, are called as network embedded system. So a program running inside a device, a program running inside the another device is called as network. Then the fourth one is the mobile embedded systems. All the devices that are portable and working with an embedded system is mobile embedded system. So portable यानी जिसको wired connection नहीं है, वो कहीं पे भी लेके जा सकते हैं. ऐसा ऐसा प्रोडक्ट जो पोर्टेबल है, जो बैटरी पे चलता है, जो वायर्ड नहीं है, अनवायर्ड है, बिल्कुल वायरलेस है. और ऐसे टाइप ऑफ सिस्टम इज कॉल्ड एज मोबाइल एम्बेडेड सिस्टम्स. Though there is a limitation of memory and functionality, its portability and handy systems are useful for all the people. So उसकी limitations रहेंगी. Obviously everything is working on the battery. Most of the limitations are related with the functionality or memory, but it is much more portable, so people prefer to use these handy systems. The systems which are portable are called as mobile embedded system. Now types of the embedded systems based on the performance of microcontroller. So इसके पहले जो देखा हमने according to the functionality था. अब जो देखने वाले हैं वो है based on the microcontroller. उसके अंदर कौन सा माइक्रोकंट्रोलर इस्तेमाल कर रहे हैं हम, उस बेसिस के ऊपर हम एम्बेडेड सिस्टम्स के टाइप्स बना रहे हैं. द फर्स्ट वन इज अ स्मॉल स्केल एम्बेडेड सिस्टम. 8-bit or 16-bit microcontrollers are used to design this and work with the help of matter in the system. So obviously small scale बैटरी के ऊपर काम करने वाला और जिसमें 8-bit या 16-bit का माइक्रोकंट्रोलर इस्तेमाल होगा, ऐसा सिस्टम एम्बेडेड सिस्टम को हम स्मॉल स्केल एम्बेडेड सिस्टम बोलेंगे. Several programming tools are used to develop small scale embedded systems. Obviously this is a small scale embedded systems, so several programming tools can be used to develop such kind of small scale embedded systems. The hardware is very small and the processor is slow. the memory is also less. As it is on the smaller scale, so everything is slow as compared to the other one. The codes for developing these embedded systems can be written with the help of IDE, that is nothing but integrated development environment. So with the help of IDE platform, the codes can be written for these kinds of embedded systems. Remember, these are small scale embedded systems, so everything is limited, and the microcontrollers used are 8-bit or 16-bit, and according to the value of the microcontroller that is being used, they are mentioned as small scale embedded systems. Now next one is an medium scale embedded system. In this 16-bit or 32-bit microcontrollers can be developed for medium systems. Now in this you can use DSPs or RISCs. Hardware and software functionalities are little complex. Several coding languages can be used as a programming tool. So you can use DSP processor or RISC kind of processors. You know that RISC is the hardware architecture that microcontroller is having. The ARM is using. So ARM is having that hardware architecture of RISC. So there are two kinds of hardware architecture, RISC and CISC. So you know that in most of the ARM are used with the RISC architectures, or it could be a combination of RISC or CISC architectures. So these kind of medium scale embedded systems actually uses DSP processors or the RISC or CISC kind of architecture. The hardware and software functionalities are complex, and several coding languages can be used as a programming tool. So obviously when you're going to use a better processor, in order in as in case of memory as well as speed, so you know that DSP is an high rate data rate application processor, where you can use a high data rate, you can develop an high data rate applications. So as far as data rate will increase the functionality and will increase as a in a complex. Then as a small scale system, an ID is required for the medium scale system also. So obviously ID के बगैर तो आप program लिख ही नहीं सकते हैं. We can use medium scale systems in high-end applications with large memory and processing data. So it is a medium scale embedded systems, and I could say that 6-bit or 32-bit microcontrollers can be used to develop such kind of systems. Now third one is a sophisticated embedded system. The most complex embedded system with all difficult complexities and hardware and software that makes a system useful for all is called as sophisticated embedded system. So obviously you can imagine lot of embedded systems working together, uh, like lot of embedded system workings together in a larger embedded system. So that could make a large embedded system. So having a complex hardware and software which will make this system a sophisticated one. So imagine that few embedded systems in an one embedded systems are medium scale, and if imagine that there are a lot of embedded systems working together or independently or a part of a larger embedded systems are nothing but the sophisticated embedded systems. So these systems requires registers of huge memory, obviously scalable processors, so you can scale those processors, and IPs so that system can work well in any environment. So obviously this is going to be a huge canvas system, like where a lot of memories, a lot of processors, a lot of hardware, software is coming into the picture and working together to uh, give a little hard, uh, give a huge output. I could say that they are all complex working together, complex hardware and software working together. Then they are used in a system with graphical screens, touchpads, and cutting edge of options, where software and hardware are equally needed for the performance. So where the software and hardware both will play equal important in designing any embedded system are called as sophisticated embedded systems. So they are huge or a part of a larger embedded systems, and make hardware, software with all the kinds of programming environment these systems can be designed. Now, the next will be the role of embedded system in IoT. Now you have understood what is embedded system, you know what is Internet of Things, you know IoT. You also know embedded systems. You are also knowing the characteristics of the embedded system. You have also seen the types of embedded systems according to the functionalities as well as according to the microprocessor or microcontroller used. So it is going to vary according to the applications. How complex the application is there. Based on that, you're going to choose the type of embedded system. Now we'll be coming to that part where the role of embedded systems should be clear in case of IoT. What is that role of embedded system that will be there in the IoT? So we'll focus on this thing. The area that are going to transform our RTOS, that is real-time operating system, microprocessors, and microcontrollers, followed by the memory footprint. So obviously memory will also come into the picture, networking, open source communities, and developers. So these all will come together. This area that is going to transform RTOS, microcontrollers, memory, networking, and the open source communities and the developers will come into the picture. Here the role of embedded system will appear in IoT. Now what is the requirement of embedded systems into the IoT? Should perform a specific task that has been assigned task to it. They must have ROM RAM. They must read the input, must have a real-time computation. So obviously they should work out in real time as we are using real-time operating system. So real-time computing means, example we can say like the cricket, the Hawkeye. Example is that Hawkeye is giving the real-time output whether where the ball is pitched, after pitching where it is going, where it is supposed to go. That is what is the real-time computation. So you can see that in cricket Hawkeye, you can see that the real-time output is taken into picture. So real-time computation is also very important. Read the input, produce the output, and timely task execution is the most important feature. When we do with real-time operating system, then the timely task will also be an important. So in order to have the embedded system in IoT, we need to have these requirement at least. Now, the examples of embedded systems, the first one is laser printer, itself an example. Then second, your digital camera. Third one is an automotive embedded system, that is that automotive in industry. You can see that the automated part which is executing is nothing but an embedded system, example of embedded system. Then your automatic washing machine that is at home, that is also an embedded system because it is having hardware as well as software. Nowadays, you know that microcontroller based washing machines are present there, where the specific time is allotted for washing the clothes. So those kind of automatic washing machines are nothing but the embedded systems. Then your personal digital assistant, industrial robots. Robots is also an embedded system which performs a particular task for a particular way. You can take an example of industrial robots like bottle filling plant. Like first the bottle will come in the first cycle, then second cycle the water will be filled into the bottle. The third one is it will be closed and then it will be pushed. This is nothing but a robotic cycle that appears in industries in order to perform a specific task. Then ATM, that is automated teller machine, then calculators. All these are examples of the embedded system. Calculator is a small embedded system. But as far as the industrial robots, automatic washing machine, these are medium scale. And when we go for little larger than this, then sophisticated embedded systems. Then what are the advantages of the embedded systems? We should also come to know about this one, that it is able to cover a wide variety of environment, less likely to encode errors. This is very much important advantage of the uh, embedded system, that is less likely to encode the errors. Then embedded system simplified hardware, which reduces cost overall. So the more the simplification of the hardware, the lesser will be the cost. Then it offers an enhanced performance, and the embedded system is useful for mass production. Then the embedded system is useful for the mass production. So in industries, you know that the production is done at a large way. So in that case, the embedded system very useful. Otherwise, it will take a lot of time. So again, time saving concept embedded system can do. It is highly reliable, so you can depend on these embedded systems. It has a very few interconnections, so obviously the lesser the interconnections, lesser the complications. The embedded system is small in size. Obviously, it can be on a single system on chip. So it could be small in size. It has fast operations. It offers improved product quality. So as the accuracy increases, the efficiency increases, the quality will increase. The product quality will be good. It optimizes the use of system resources, and it has low power operation, so obviously low power consumption will be there. These are the advantages of the embedded systems. Then if there are advantages of the embedded systems, that means there are also disadvantages of the embedded system. Now what are the disadvantages of the embedded systems? First is, to develop an embedded system needs high development effort. Yes, obviously you cannot design an simple embedded system uh, uh, you cannot design it properly. You need a high development effort to go for any like simple or it may be complex embedded systems. The effort has to be there on the development platform. So if you're going to develop an embedded system, you need to put a very huge amount of effort, and that effort is nothing but the disadvantage. It's not a disadvantage if you want to go it for a proper embedded system. You need to put an effort. So I could say that this is not an disadvantage, but yes, it could prove an advantage if you work on it. Then it needs a long time to market. Obviously, it is a long time process, so it requires a long time to settle into the market. Then embedded systems do a very specific task, so it can't be programmed to do different things. Obviously, you're going to design this embedded processor for a specific task, and if you want to again go for the another task to be performed, then the whole program has to be rewritten, or make hardware changes, make software changes accordingly. So obviously that is a very typical task, very tedious task to change all the hardware, software. So better is that like you're going to design an embedded system for a particular task only, and when that finishes, you go for the next task, design it differently. So that is what the disadvantage of the embedded systems are. Then embedded systems offer a very limited resources of memory for memory. Obviously, memory is a factor in case of embedded system, because if you're going to write a huge program, then it requires a lot of memory in that. So it is having a limited source of memory. It does not offer any technological improvement. So if you are going to design it for a specific task, so I said that you need to have a particular hardware or software doing that task. So uh, if you want to make changes in that, it does not offer much more things, because you have designed for a particular task only. So if you want to design a new task, if you want to go for a new task, then you have to go with different hardware and software and requirement according to the applications. Then it is difficult to back up the embedded files. Yes, because as it is having a limited resource of memory, you cannot back up a lot of data of the embedded files. So this is how the embedded system is about. Again, I'll revise it for few minutes. So we have seen system, then we have seen embedded, then embedded system, Internet of Things. Then we know that embedded of this importance of this chapter. Instead of saying course, it's importance of the chapter we have seen. Then embedded system, it could be an independent system or could be a part of the larger system, and they have been designed to perform specific task only. And example is fire alarm could be an embedded system. Then the characteristics we have seen that single function is doing itself and repeatedly. In tightly constraint, we have seen that it has constraint on design metrics, like implementing the features such as cost, size, power, and performance, and it should fit on a single chip. So it could perform very fast as well as less consumed, so that battery life will be there. Then reactive and real time. So obviously, uh, for controlling purpose, it could react to the changes that is happening in the system environment, and there should not be certain. It should calculate in a certain real time way without any delay. Then memory, obviously, it does not have a secondary memory. usually stores on ROM. Then it should having connected peripherals to connect input and output. Hardware and software provides the features and flexibility. Hardware for performance and security. Then this is the basic structure of the embedded systems: sensor, A to D converter, processor, memory, a D8, D to A converter, and actuator. Then this is the types of embedded systems. So depending upon the functionality, it is real-time, standalone, networked, and mobile. Whereas the performance based on the microcontroller, small scale, medium scale, and sophisticated scale. So standalone is an does not require any host like computer or processor. It could work itself and make necessary changes. Second is a real time. It is completely in real time. Task is stipulated, given for a specific task is performed with a speculated time. So it comes as a savior of the time. Then in case of network, device running, software running in the device, which is in the another device, and program running inside an another device is called network embedded. Mobile, it's an portable and handy system that could be useful for the people. Then comes small scale 8 or 16-bit microcontrollers can be used to design. Then it is small, processor is slow, the memory is also less. Medium scale 16-bit or 32-bit, sorry, 6 is written there, it's a 16-bit or 32-bit microcontroller is used to develop medium system. All these can be developed with a DSP processor or RISC processors. It's a small scale. ID obviously is required, and high-end applications with large memory and processing the data can be done. Then a sophisticated embedded system, you can see that it's having complex software as well as hardware. It requires huge memory, scalable processors together working, and the system can also be with graphical schemes, touchpads, and cutting-edge options where the software and hardware are equally needed. Then role of embedded system in IoT. So the embedded systems are low power consumption units that run to a specific task. For example, remote control washing machine, RFID tags, sensors, and thermostats. The network hardware such as switches, routers, modern mobile phones, PDAs, etc. Usually, the embedded devices are the part of a larger device where they perform specific tasks. In automation, embedded systems are used as a wired or wireless networking to automate and control light, changing in the environment, climate change, monitoring, all these things. The area that is going to be very important is that what kind of requirement the embedded systems are having in IoT. So they should perform specific tasks, must have RAM, ROM, must read input, real-time computation should be there, produce output, and timely task execution. Examples are the automatic washing machine and automotive industrial automation, then automated teller machine, calculator, robotics, automotive embedded systems. Some of the advantages: small in size, faster operation, offers product quality, low power operation, offers an enhanced performance. Disadvantages: does not have a backup of the embedded file, does not offer any technological improvements, and having a limited source of memory and is been designed for a very specific task. Beyond that, it cannot be used. So if you want to change it, you have to go or build up a new embedded systems. So the last part will be the applications of the embedded systems. So the robotic science used in robotic science, like ground vehicle, drones, underwater vehicles, industrial robots. Second, medical, that is dialysis machine, infusion pumps, cardiac monitors. Third, automotive, like engine control, ignition system, brake system. Fourth, networking, like router, hubs, gateways. Fifth, home devices like TV, digital, air conditioning, DVD players, cameras. And sixth, automobiles like fuel injection, lights in lighting system, door locks, airbags, windows, parking assistance system, etc. So I hope that it is clear. I have tried to cover the whole point starting with the embedded systems. Uh, yes, student, is it clear? Hello? Hello?